So the jar is filled with blue and green and red marbles, and they're drawing some marbles. Then they also add white and orange. I probably didn't have to write out the color names. But anyway, so we have 5 different colors in there. What's the probability that an orange marble will be drawn from the jar? Remember that probability is equal to the desired outcomes, namely an orange marble, over the total number of outcomes, which would be blue plus green plus red plus white plus orange. So if we can get all of these, the numbers that each of these variables represents, we will be able to compute the probability. Isn't that great? So statement 1 tells us that 15 orange marbles are added to the jar. This tells us O equals 15, but we don't have any of the other marble numbers. So this is not going to be sufficient on its own. We get rid of A and D. Statement 2 tells us there are equal numbers of each colored marble in the jar. And at first glance, this sounds like it wouldn't be enough because we don't have any numbers. The key here, though, is that it says there are equal numbers of each colored marble in the jar. If you have 1 of each, your chance of getting orange will be 1 in 5. If you have 10 of each, again, because there's always equal numbers, your chance is still 1 in 5. It's 10 out of 50. Any number that you pick, if you put the same number under each column here, the fraction will reduce to 1 in 5. So statement 2 on its own is sufficient to tell us your chance of getting an orange marble is 1 in 5, even though we have no idea how many marbles are in the jar. Statement 2 is it. So answer choice B is it.